Hello everyone. Let's dive straight into a distinction that causes a lot of confusion in boardrooms but is absolutely vital for your AIGP exam. The difference between a machine that just follows orders and one that actually decides. Now, according to the official study guide, automated systems are defined as those that function with little to no human intervention by following a predefined set of rules or a fixed script to perform repetitive tasks. Think of it like this. An automated system is like a very loyal, very fast train on a track. It can go incredibly fast and it doesn't need a driver to push the pedal every second. But it can only go where the tracks have already been laid down. If there's a fallen tree on the tracks, the train doesn't decide to go around it. It just follows the rules until it hits the obstacle or a sensor tells it to stop. You might have seen this at work with those out-of-office email replies or even a simple Excel macro. If X happens, then do Y. I remember a project where a company wanted to AI enable their payroll. When we looked under the hood, it wasn't AI at all. It was just a very complex automated script. It didn't think about whether an employee deserved a bonus. It just checked if the bonus box was ticked and added the numbers. It's reliable, predictable, and from a governance perspective, relatively easy to audit because the rules are written in plain sight. Now, let's pivot to the more complex sibling. The official study guide describes autonomous systems as systems that can change their behavior or reason in response to unanticipated situations, operating with a high degree of independence from human control by making their own decisions based on sensory input and learned patterns. Think of it like this. If the automated system is a train, the autonomous system is a self-driving car. There are no tracks. The car has to look at the world, see a pedestrian, realize it's raining, and decide in real time whether to brake, swerve, or slow down. It isn't just following a predefined script, because you can't write a script for every single possible thing that could happen on a busy city street. Stay with me for a moment, because this is where the governance part gets spicy. I once sat in a meeting with the chief privacy officer who was terrified of a new autonomous customer service bot. Why? Because unlike the if X then Y script, the autonomous bot was learning from every chat. It was deciding on its own how to handle a frustrated customer. When a system starts making its own choices, we can't just audit the rules anymore. We have to audit the logic and the learning process. This brings us to a concept that often shows up in risk assessments: unpredictability. The official study guide notes that while automated systems are deterministic, meaning the same input always produces the same output, autonomous systems can be non-deterministic, meaning they might react differently to the same situation as they learn and evolve. Let me show you how this looks in a simple dummy example. Imagine an automated coffee machine. You press the latte button and you get a latte every single time. Now imagine an autonomous robot barista. One morning, it might decide that because it's a gloomy Monday, everyone needs an extra shot of espresso. Then on Tuesday, it might decide the milk is getting too warm and stop serving lattes altogether. You see the challenge? In a workplace, unpredictability is a nightmare for legal compliance. If an autonomous hiring tool rejects a candidate today, but would have accepted them yesterday because it learned something new in between, how do we ensure fairness? It's like trying to catch a cloud. It's always changing shape. We'll take it slow. But keep this in mind. Automation is about efficiency, but autonomy is about agency, the power to choose. Now, it's not always a yes or no thing. We often talk about the levels of autonomy. According to our official study guide, autonomy is often viewed on a spectrum ranging from human in the loop, where the human makes the final call, to human on the loop, where the human monitors and can intervene, to human out of the loop, where the system acts entirely on its own. Think of it like teaching a teenager to drive. Human in the loop is when they are in the driver's seat, but you have your hand on the emergency brake. Human on the loop is when you are in the passenger seat, scrolling on your phone, but ready to shout stop if they miss a red light. Human out of the loop is when you wave goodbye as they drive off to college alone. In your AIGP role, you'll spend a lot of time arguing about which level is appropriate. For a system that recommends what movie to watch, Out of the loop is fine. No one gets hurt if the AI recommends a bad comedy. But for a system that determines medical treatments or credit scores, you probably want a human in or at least on that loop. Now watch how this connects to the idea of accountability. If the human is out of the loop, who gets the blame when things go wrong? To make a system truly autonomous, the quote-unquote engine has to be much more complex. The official study guide explains that the technical stack for autonomous systems requires a combination of advanced sensors, real-time data processing, and complex machine learning algorithms that allow the system to map its environment and predict future states. Think of it like the difference between a basic thermostat and a smart home system. A thermostat is automated. It feels the cold and it turns on the heat. Simple. But a smart home system that quote notices you are coming home early, quote sees that you are carrying groceries, and quote decides to unlock the back door and turn on the kitchen lights? That needs cameras, GPS data, and a quote brain that can put all those pieces together. I recently talked to a data scientist who was building an autonomous drone for crop spraying. He was explaining that the drone has to see the difference between a weed and a watermelon while flying at 30 miles an hour. That's not just a script, that's a high-speed conversation between the sensors and the AI brain. As governance pros, we have to make sure that the technical stack is robust. If the sensor gets a smudge of dirt on it, does the autonomous system know it's blind? Or does it keep making decisions based on fuzzy data? We've covered the loyal trains of automation and the independent drivers of autonomy. To wrap this up, the official study guide reminds us that the primary goal of AI governance is to ensure that the level of autonomy granted to a system is proportionate to the risk it poses and the reliability of its technology. Don't worry, we'll take it slow as we move into the actual risk frameworks, but I want you to remember this. Higher autonomy isn't always better. Sometimes you just want the train to stay on the tracks. If you're building a system to sort internal emails, keep it automated and simple. But if you're building a system to detect cyber attacks in real time, you might need that autonomous thinking speed. I always tell my students, being a great AIGP professional is a bit like being a parent. You have to decide when to give the child, the AI, more freedom and when to keep the leash short. You're doing a wonderful job grasping these foundations. These are the building blocks that will make the legal and ethical sections so much easier later on.